All right, now I'm going to solve problem 36 from the Chapter 2A homework assignment. This is the one about the two brothers that are leaving the house and going to a lake in separate cars. So I'm going to read through the problem and talk through a process for doing it. And so first, let's see. You and your brother both leave your house at the same instant and drive in separate cars along a straight highway to a nearby lake. After 10 minutes. Okay, something's happened after 10 minutes. What happens? Oops. After 10 minutes, you're both 3 kilometers from your house. You're now driving at 100 kilometers per hour, so presumably your speed changed at that moment and you were going some other speed during that first 10 minutes. And you continue at this constant speed. Your brother is now going faster than this. After another 20 minutes, your brother arrives at the lake. Your brother arrives another 20 minutes later, but you're still 5 kilometers away. And ultimately, we're going to figure out how far is it from your house to the lake. How far from your house to the lake, and what's your brother's average speed for the trip, and how much does your brother beat you by? What's the time interval they win this little race by? Okay. First thing I'm going to do is I'm going to try and draw this out because this is kind of a confusing story, and I want to make sure that I have something marking down, like my coordinate system, the starting point, the lake, things like that. So we start right here. Let's call this the origin. This is the house. That is my 0 point. And I'm going to do a green line for myself and a red line for the brother. So green line, we start out traveling. And after 10 minutes, we're both 3 kilometers from the house. Okay, so something's happened after 10 minutes. We're 3 kilometers away. So this distance right here is 3 kilometers. And during that time frame, because we both started at the same time and we both ended that 3 kilometers at the same time, we must have been traveling the same speed. So whatever our speeds were, it was the same during that time frame. And since we have a time and a distance, we can figure out what that time is. So that's the 10-minute mark. Okay, then from there, you or I travel at 100 kilometers per hour. So I'll mark that down, 100 km per hour. And we keep going for a ways. The brother is now traveling faster than that, so some other speed forward. And they go at that continuous speed constantly for another 20 minutes from that moment. So there's another 20 minutes. So the moment that the brother arrives at the house, at the lake, is a total of 20 minutes more, or 30 minutes total. So let me mark that as 30 minutes total. And at that exact moment, you are still 5 kilometers away from the house. So there's another 5 kilometers to go to get to the lake, sorry. And you continue at a constant speed after that. So you don't change your speed for that last little bit. And that's when you catch up. Okay, so I have a little bit of a picture. It's still a little bit confusing. Maybe it would help to have a position versus time graph showing the times and speeds and times and distances and things like that. Maybe. It's basically always a good idea to have a position time graph. So let's make one. So I'm going to say position time in minutes. Okay. And I have several different important times. So I've got 10 minutes. That's the 10-minute mark. I've got the 30-minute mark. That's going to be right there. And then whatever time I finish, which I don't know what that is yet. Okay. During, and then let's see. We both start at the house, and we both travel at the same speed for those first 10 minutes, and we travel 3 kilometers. So we got that and that next to each other, traveling for 3 kilometers. Okay. Then for the next 20 minutes, the brother travels at something faster than 100 kilometers per hour, and you travel at 100 kilometers per hour. I'm not quite sure how to draw the slope of this yet, so I'm going to hold off on that one. Okay. So let's see if I can kind of, I'm not quite sure what my general strategy is. I don't have a really clear plan yet for what I want to do. I know that I need to figure out how fast we're all going so that I can figure out how far we've traveled during that 20 minutes. Because that's really the thing I don't know. Like if I'm looking at this middle part, I don't know what this distance is here during which I'm traveling 100 kilometers per hour, the brother's traveling faster, and they have finished the entire race. So let's see if we can figure that out. First, I'm going to figure out this distance between the house and the point where we separate. Then I'm going to try and figure out this distance when we're traveling different speeds. All right, so 1 from the house to that split point. House to split. We're both traveling the same speed. We travel 3 kilometers. Distance equals 3 kilometers. Time, duration of time is 10 minutes, which I'm going to write that as 1/6 of an hour. 1/6 hour. So the speed during that time, the average is 3 kilometers over 1/6 of an hour equals 18 kilometers per hour. So that's the speed during those first 10 minutes. That's not very fast, especially if we're going 100 kilometers later on. Okay. Next part. Part 2, when we've split up, we've got the brother traveling at an unknown speed for 20 minutes more. At unknown speed. For 20 minutes. And during that time, they cover the rest of the distance to the lake. And you, on the other hand, are traveling 100 kilometers per hour. So we do know how fast you're traveling. You are at V equals 100 kilometers per hour for 20 minutes. So we know how far you must travel, or we can figure out very quickly how far you must travel during those 20 minutes because we know your speed and we know the time. Okay, so 100 kilometers per hour equals the distance over the duration of time. The duration of time is 20 minutes out of 60 minutes of an hour. So if I rearrange that, that gives me delta x equals 100 over 3 kilometers per hour. Kilometers, sorry. So that's 33 1/3, but I'm going to leave it as a fraction for the moment because I think it's going to be easier to deal with some other stuff in a minute. Okay, so I know how far I must have traveled, and I can now go back up to this drawing up here and add in one more detail, which is that that distance must have been 100 over 3 kilometers. 100 over 3 kilometers. Between the split point and the point where you get at the moment that the brother finishes. So 33. So that means this graph that I drew is going to be hard to maintain a consistent scale. During those 20 minutes, you travel basically 33 more kilometers right there. You're going pretty fast at that point. But this scale that I've drawn is not very consistent because I didn't really know how to plan it. Maybe I'll fix it later on when we finish the whole problem. Okay. So then what else can we know? Well, now we know it's another 5 kilometers to the finish, and I'm still traveling the same speed, so I can figure out how much longer it takes me to finish. So number 3. So you, put that in green again, you have v equals 100 kilometers per hour, and the distance that you're covering is 5 kilometers. Delta x equals 5 kilometers. So that means since velocity is distance or displacement over duration of time, 100 kilometers per hour equals 5 kilometers over delta t. And that means the delta t is going to be 5 over 100 hours, which is 1/20th of an hour, which is 3 minutes. Or 3 minutes. So it takes another 3 minutes for you to finish after they do. Okay, so that means you're going to finish at time 33 minutes, and you're still traveling the same speed as before, so this slope doesn't change, and the finish time for you is at 33 minutes. And now we got to figure out stuff about the brother. We know exactly your whole story. You travel at 18 kilometers per hour for the first 10 minutes. Then you travel 100 kilometers per hour for the next 23 minutes, and that's when you finish. All right, so what can we figure out about your brother? And also the total distance traveled. Okay, so part A, total distance. Total distance is the 3 legs of the trip. So we figured out, or we know that the first leg is 3 kilometers, the last part is 5 kilometers, and this middle part is 100 over 3. So the total distance is going to be 3 plus 100 over 3 plus 5 kilometers, which is 33.3 plus 8, which is about 41.3 kilometers. Let me make that a better decimal. Okay, so total distance is 41.3 kilometers. What next? Looks like I need a new page. So B, question B was, what is your brother's average speed for the entire trip? Okay, so the brother's average speed, we know that they travel 18 kilometers per hour for the first chunk of time, same speed as you, and then they travel at some other speed for 20 more minutes. Okay, and we know what the total distance they traveled during that time is. So then we can figure out what their speed must have been during that time. We don't necessarily actually need to know what their speed was during that chunk of time, because we know what the total distance they covered was, and we know how much time it took to do it. So that's actually a more straightforward way to do this. So we can figure out their average velocity, average speed, by saying how far did they travel and how much time did it take. Well, we know the distance they traveled is the 3 kilometers plus the 33, they covered the entire distance, 41.3 kilometers. And the total time it took is the 10 minutes when you're traveling at the same speed, plus the 20 minutes when they're traveling faster than you. So that's a total of 30 minutes they're traveling. So 30 minutes out of 60 minutes per hour. So half of an hour. So that works out to 82.6 kilometers per hour. must be their average speed because we know the distance is 41.3 kilometers and we know it took them half an hour to cover that distance. Awesome. Okay. Finally, how much time does it take you to catch up? We actually already figured that out. We already figured out there was an extra 3 minutes. That's how we got this graph right here. And we figured that out here when we said you're traveling 100 kilometers per hour for an extra 5 kilometers. That takes 1/20th of an hour, which is about 3 minutes. So you finish 3 minutes later. And that's it for the questions they're asking. So let me quickly fix this graph, and then we can be done. So they finish after 20 minutes after you've separated, which means they get to this distance right here, the 41.3 kilometers, and they do it in just 30 minutes. So that's right there. So their graph is slightly steeper than yours for those 20 minutes. And they finish 3 minutes ahead of you. So this gap right here on this graph shows the extra time that they had at the lake ahead of you. All right, that's it for that question. Let me know if you have any follow-ups, and I'll see you later.